So let's start by discussing what a database actually is. So we can define a database as being a collection of information about a group of similar items. For example, if we had a cat called Rosie, a dog called Mac, and a hamster called Rambo, you could collect information about all of these individual items in a database called pets. And let's take this a little bit further for a second. What if we had information about the age of each of these pets? All that could be stored in our pets database. Same with information about the type of pet each one of these items are. And if we stored information about the type of food that each of these pets liked, we're starting to build up quite a comprehensive database. And if we start to try and formalise the information, it's almost like we're creating like top trump cards with information about each of the pets on it. And this is how a database is structured electronically. We have individual cards, which we call records, and each of these records holds a number of pieces of data about that particular item, and these are known as fields. And as you'll learn in a second, these fields each have their own field type. So for example, if we think about the name field type, the names Rosie, Mac and Rambo are all text. So the field type for this information would be text. The same is true for the type field because it's cat, dog and hamster, so that's also text. And exactly the same for prefers, because prefers fish, sausages and lettuce, they're all text too. The age field is slightly different. It's obviously numeric, so we have 14, 8 and 1, and so we can say that that's just a number field. Although you could go into more information and say it's a whole number, so an integer number. On the next page, I'm going to show you how we would lay this out in a design for a database, which is also called a data dictionary. So what is a data dictionary? Well, simply put, it's the description of the structure of a database table or entity. And it contains some important information. And it contains things like the field names and data types, a suggested size for each field, the format if we want to force it to be in a fixed format, rules about validation of data that's entered into the database table, and key constraints, and we'll learn more about that later on in another lesson. And the way you structure your data dictionary, well, it depends on what you want to hold information about, but the easiest way to design it, or the most common way to design it, is to have a list of the field names, their data types, and then other information that relates to that field. So let's fill this in for our pets database from the previous page. So as you can see, we've got the 4 field names that we identified in the different cards on the previous page: name, type, age and prefers, and their associated data types. So text for 3 of them, and for age we've got an integer number. Now, in other information, we might want to put things like suggested size and whether there's any validation and things like that. So let's try and figure this out. So a pet's name is usually quite short. I mean, you would only have the first name. Maybe if it was a pedigree, you would have a longer name. So let's set a suggested size of 30. And while we don't have to use all 30 characters for each pet name, it's nice to know that we could have a pet's name that's as long as 30 characters. For the type of pet, that's probably quite short, so we could have maybe just 10 characters for that field. When it comes to age, we probably won't have a pet in our database that's over 999 years old, but we might have one that's over 100, so maybe like a tortoise or something like that. So we could have a field size of 3 digits. And the last one, their preferred food, maybe we'll make that field size 30 as well. Now, there's not a prescribed format for any of these fields, so we're not going to look at format at this point, but we have the ability to have some validation. So we can set the minimum and maximum age of a pet if we wanted to. So let's say we wanted to do that. We could just say that the range of the age had to be between 0 and 150. And that means that you can't have a negative aged pet, and also your pet cannot be older than 150 years old. So that's an example of a very simple data dictionary, and that's used by a database programmer to create the actual electronic database that data about pets would be stored in. Let's finish this video by just briefly discussing the different data types you might encounter when you're creating a database. We've already talked about text and number, and hopefully that's self-explanatory. But other data types exist in databases which maybe don't relate to the data types you know about from programming. Boolean, for example, is a true or false value, which we know about from programming, that can be used to store yes or no responses in a database. For example, if we were trying to add this to our pets database, we might create a field called has inoculations, and you would set it to true if the pet has inoculations, and you would set it to false if they hadn't. Datetime is another data type that you might not be aware of, and this could be used in a database to store information about when the pet was last at the vet, maybe or last got a checkup or anything. Could be the date and time it was born, if that was useful. So datetime is a really useful data type that you will want to use in your own database designs. One last data type, and there's more than this, is an image data type. And so you might want to have a field in your database or your database table which holds a photograph of your pet. It's maybe going to be used in a large vet surgery, and they need to know that the pet they're looking at is actually the pet which has had the inoculations and maybe hasn't been checked up since a few years before. So an image might be useful to identify the individual pets in this instance.